Part 1 of this video explained why we see phases of the moon. Now, in Part 2, we'll explain the times of moonrise, highest point, and moonset shown under each phase in this figure from your textbook. Note that you do not need to memorize these times. Instead, we'll show you how to use a simple diagram so you can always figure them out for yourself. To create your diagram, start by showing sunlight coming in from the left. Add the Earth, showing that the half facing the sun is in daylight and the other half is in night. Now, using a view looking down from above an Earth's north pole, draw a counterclockwise circle for the moon's orbit. We'll start with the moon here at the new moon position. Remember that all orbits and rotations for the Earth and moon are in the same direction, with the moon orbiting Earth and going through its cycle of phases in about a month, and Earth rotating once every day, or 24 hours. From part 1 of this video, you should already know how to place the moon in the correct position for each phase. To review, this is the new moon position, where only the moon's night side faces Earth. We then go to waxing crescent, first quarter, waxing gibbous, full, where we see the moon's entire daylit side, waning gibbous, third quarter, waning crescent, and back to new. To learn how to find the times of day at which each phase rises, reaches its highest point, and sets, we'll remove the moon for now and place a little person on Earth. As Earth rotates, it is day for this person on the left side of the diagram and night on the right side. Note that, for simplicity, we are essentially assuming that the person is near the equator, where there are 12 hours of daylight and 12 hours of darkness. More specifically, this starting position represents noon for this person because the sun is overhead, while the opposite position represents midnight. Continuing Earth's rotation, this position represents sunrise because the sun is just coming into view. We again reach noon and continue to sunset. Before we continue, check your understanding by answering this question. For this diagram, what is the phase of the moon and the time for the person shown? Is the person seeing a full moon at noon, a new moon at noon, a full moon at midnight, or a new moon at midnight? The answer is C. The moon is full because it is in the position where we see its entire daylit side, and it is midnight for this person because the sun is on the complete opposite side of their sky. Notice also that the full moon is directly over the person's head in this position, so we conclude that when it is full moon, the moon passes overhead, or more generally through its highest point in the sky, at midnight. Now let's figure out when we see the full moon rise and set. To help us remember the key points, we'll put a little diagram of the moon phase positions in the lower left corner, and a diagram of the time of day positions in the lower right. Since the full moon is at its highest point in the sky at midnight, it must drop lower in the person's sky as the night continues, reaching the horizon when the person reaches the sunrise position. In other words, a full moon sets at sunrise. The full moon is then below the horizon throughout the daytime, rising when the sun sets. This should make sense because the full moon is exactly opposite the sun in our sky. Therefore, a full moon rises when the sun sets, reaches its highest point at midnight, and sets when the sun rises. Let's apply the same procedure to a first quarter moon. First, we place the moon at its first quarter position. Next, we put a person in the position where the first quarter moon is overhead. Notice that this is the sunset position, so we conclude that a first quarter moon is highest in the sky around sunset. Now try this question. What time does the first quarter moon set? Is it around sunrise, noon, sunset, or midnight? The answer is D, midnight. To see why, let's return to the larger diagram, where we've already seen that a first quarter moon is highest in the sky around sunset. Therefore, as Earth rotates, it must set about 6 hours later, or around midnight. It then remains below the horizon until the following noon, which is when a first quarter moon rises. In other words, a first quarter moon is visible throughout the afternoon and into the evening, setting at midnight. Let's do one more together to summarize the procedure. We'll consider a waning crescent moon. Step 1. Place the moon in the correct position for the phase. Step 2. Put a person in the position where the moon phases overhead and determine the time. In this case, the person is about halfway between the sunrise position, which would be about 6 a.m., and the noon position, so it is approximately 9 a.m. when the waning crescent moon is at its highest in the sky. Finally, because the moon is highest at 9 a.m., it must have risen about 6 hours earlier, or around 3 a.m., and it will set about 6 hours after its highest point, or around 3 p.m. You should now be able to figure out the rise, highest point, and set times for any moon phase. Start by drawing a moon phase diagram and placing the moon in the correct position for the phase you are considering. Next, put a person in the location where this moon phases overhead and figure out the time for this highest point of the moon. Then, just subtract and add 6 hours to find the rise and set times for this moon phase. Remember that the times we found are approximate. The exact times vary with your location and the time of year.